Okay, I'd like to show off a tool I've made. It's called Irregular Tuning Maker. On some of the videos that I posted, well, on all of them, it says Irregular 17 Edo tuning. Nobody's asked what that means, but I imagine that of the few people who watched it, some people are wondering what that means. So I'm gonna show off a tool that I built to make these irregular tunings, and it kind of, well, I don't think I'll explain exactly what those irregular tunings are, but I'll show this tool and I'll hopefully show you the value in using this kind of tuning. Okay, so let's start at the top. Right now I've got my scale space here. I've chosen 12 Edo. At the moment there's only 5, 7, 12 and major scale. Let's stick with 12 for now. Okay, and then here is the scale range. Pretty simple, pretty simple. You can also press Control plus to make that go up, minus to make it go down. Yep. Table. Okay, so here it's showing the size of the interval. So like for example 1.5, that's the fifth, that's 3/2. If I type in 3/2, it's going to give 1.5 as well, so nothing's changed. So it can accept fraction input. If I press this display mode here, we can show the size as cents as well. These are in scientific notation, just because if you make the scale have a really wide range, you know, some of the cents values, they get a little bit difficult to read, so that's why I put it in scientific notation. Weight is part of the way that this way of making tunings calculates tunings. So let's take it again, for example, 1.5. This is the weight of the interval. Its weight is 0.1666 recurring. How is that calculated? It's calculated by the weight function, which is here it's selected. It's called inverse Benedetti. That's how it's calculating all of these weights. Again, if you're wondering what weights are, they tell the tuning algorithm how important it is to get that interval in tune. So let's look at the weight functions. At the moment I've only got 3 weight functions, and in fact 2 of them aren't even weight functions, because uniform just gives everything a weight of 1, and arbitrary is just allows you to change the weight manually by typing in. If I was to try to do that on inverse Benedetti to like 0.5, that is going to accept that, and then it's also going to change the function to arbitrary. So now I can change any of them. Something you might have noticed or not is that the interval from note 1 to note 8, that has the same weight as the interval from 8 to note 1. And the reason for that is because they are effectively the same interval, right? If we go back to showing the size, it's 1.5, 3/2, or 0.6 recurring, or 2/3. And then the next thing is weight attenuation. This is pretty simple. I'll just show it now. It just makes all of the weights closer to each other if I attenuate. So it just means that whatever the weight is coming from this function, they're all closer to equal if you turn it up. If it's in the middle, then you're just getting the function. If you turn it down like this, then they're all getting more and more spread out. Display precision is pretty simple. You just it just shows more decimal places. And then what else have we got? File control. Yeah, so there's a few scale spaces built in, but you can also make your own scale spaces. For example, let's say I wanted to make some kind of pentatonic scale. So I could do like this, 1, 2. What I'm doing there is I'm clicking on the note itself. I could also click on the row to select that one. And now imagine it as though, like, if you click on the column, you are putting that note into your scale that you're going to try to tune. So if I click on this one, now I've got C. Let's just say it's C. We're in the key of C major. We've got C, we've got D, we've got E, we've got G now, we've got A. Now we would also want C again, so I could click on that to select it, or if I click Control and then click on C, it's going to select all of the C's. You see now this one is selected, this one is also selected, and yeah, you can't really see it when it's black. I don't really know why that is. Maybe I'll fix that later, but just trust me when I say that this one, this one, this one, this one, this one, and this one are also selected. Now the good thing about that is let's just use this to show like multiple examples. Okay, so let's say not multiple examples, but I mean demonstrate multiple things. Okay, so let's clear the selection. You've got delete, insert after, insert before, so you can clearly change these scale spaces. But let's just say I want 2 octaves. So again, I'll select these guys, select them up. Now all of these are selected, all of these are selected, but now I've got 2 octaves of this pentatonic major scale. So I'm going to press save as. Let's just save it as a demo. Press save. It's scale space.itm. That stands for Irregular Tuning Maker. Save demo. Now what's interesting is if I go back now, zoom down, I can see that I have my 1 octave of the pentatonic major scale and I have my 2nd octave. What's interesting with this is, let's say I wanted to change this interval here, which is a 7th. I don't want it to be 1.778. I want it to be 9/5. I can do that now. I can set that to 9/5. And if you look down here, 6, 2, this one is also going to change. Okay, good, yes. So now my minor 7th is 1.8, is 9/5. If I'd had it the same way in the 12 Edo, and I tried to change that interval before to 9/5, that would have also affected this interval here, which is not what I want. Oh, sorry, this interval here, which is not what I wanted. This is now 10/9. I don't want that. I want 9/8. I guess I should kind of explain what is this scale representing, because obviously this is not 12 Edo. This is some kind of like just intonation tuning of the chromatic scale. So it's not 12 Edo. So what is it? Well, these intervals, they are the ideal tuning of that interval. I keep coming back to 1.5. That's ideal. Ideally, the 5th would be tuned to 1.5. In reality, it's often not possible to really tune it to 1.5, to tune it to 3/2. So that's the point of this part of it, which is the irregular tuning maker. Okay, so let's show an interesting example. I'm going to do 7 Edo here. 7 Edo is like this. Now the thing about 7 Edo is that it doesn't exactly work. You want your 4ths and 5ths to be close to 4/3 and 3/2, just because of the way that dividing the octave up into 7 equal pieces, it just doesn't work. They're pretty far from it if you were to actually tune to 7 Edo, but you still have these ideals. This is what you would like it to be if somehow that was possible. But I keep gesturing towards this interval, the one from note 1 to note 5. But all of these are also 5ths, and they're treated exactly the same in the irregular tuning maker. Like, let's say I just know I want my 5ths to be really in tune, and I want my 4ths to be really in tune. But I don't care as much about these two. And that's kind of what the inverse Benedetti function does. There's other functions that would do something similar, but this is the one that I've programmed. So I put the weight here. So now you can see that this one's weight is higher than this one. So I'm going to do 2 examples, one where it's fully attenuated, one where it's all the way down. And the reason for that I will explain later. I'm also, in this example, I'm not going to use the octave because it kind of throws things off because its weight is so much higher than all of the other ones. So I've got the precision all the way. I'm going to press make. And now here is our tuning. Okay, so I'm just going to copy this and I'm going to put it into a spreadsheet. Next, let's make the attenuation very high now, and then make again, and then we can copy that again, and let's put it into a spreadsheet, and then we can explain the difference. Okay, so here is the analysis of the 2 tunings of 7 Edo. This is the interval here, this column is the interval, this is the low attenuation, high attenuation tuning. These are the ideal versions of that interval. And then this is the average of that interval's representation in each tuning. This is the average of all of the seconds between all of the notes, not just this second between the lowest note and the second lowest note, because these are the extremes of attenuation. Here, with the low attenuation, all of the representations of the ideals, they're further from the ideal in the low attenuation than the high attenuation, except for the 5th, which was the highest weight, and that one is lower. This example here kind of shows in principle the benefit of this way of making tunings. Just going back to the app again, if I make the tuning very large, let's say I set the range to like, I don't know, let's say 4 octaves. So 4 octaves, that's a reasonably large, well, it's not a large range really, but it's larger than 7. Now, if I have the maximum precision and I press make, it seems to be stuck on 0. And I'll tell you, just knowing the math, this is going to be stuck on 0 forever. So just don't go for maximum precision when you've got lots of notes. You can turn it down, and to be honest, I suspect that the difference between low precision and high precision versions is actually not great anyway. So you could try experimenting and see exactly how different the two are, but I think there's not much difference. So I'm going to press cancel, and it's going to give me this back again. If you didn't want to have this on the screen, if it was annoying you, you could just press clear. And I'm going to do the same thing again, but now I've lowered the precision, and let's see what happens. Let's go a little bit higher and see what happens. Still stuck on 0. Okay, so then this is where it just becomes about tuning it. So no pun intended. Let's tune it down to here. It doesn't really matter what we do with the weight attenuation. Let's bring that down. There we go. Look at that. Okay, so that was faster. And then here, yeah, so it can be slower. But I mean, you know, if you're making a tuning, you could just, and you really, for some reason, really wanted it to be very, very accurate, you could just switch it on and leave it running. Right, so let's look. I think this is the last thing I want to look at, which is kind of show off one of the interesting things about this type of tuning. So I'm going to copy this and put it into a notepad again. So now if you look at the tuning, your octaves here, they're not exactly pure. But something else that's interesting is that all of the intervals, or like all of the fifths, are going to be a little bit different from each other. I don't know, for me, from an aesthetic perspective, I just find that kind of interesting. I find it kind of appealing. I don't like the idea of uniformity. This is obviously aesthetic, so if you don't feel that way, then that's fine too. Or if you do feel that way, but you don't feel like this is an instance of that or something, then also fine. I'm just talking about personally. I just like the way that these tunings are a little bit unpredictable. It's kind of like a black box when you just press make and you just hope that it's going to come out with something that you want. I think that's pretty much all I wanted to show about this program. I'm going to put a link to it under this video so you can download it and have a go. I wanted to have a weight function that would give the harmonic entropy, but I'm not clever enough to do that. And I haven't made any more scale spaces. There's a good chance that if you download it now, you will see there are more, but at the moment I've only got these 4. Let me know what you think in the comments. Any questions? Yeah, I think this is kind of cool. Okay, that really is the end of my rambling now.